Oh, hey everyone, Justin again. Good news, the tire's fixed. But we still need to get the oil changed, and it looks like it might be a few more minutes. So while we wait, I've been looking at the different supplies in the shop. There's oil, coolant, transmission fluid, brake fluid. Oh, you're right, Mia. These two bottles have different fractions on their labels. But check this out. The bottles are the same size, and the liquid inside reaches the same level. Can two different fractions really represent the same amount? Well, by the end of today's lesson, you'll be able to define and identify equivalent fractions. And you'll be able to create equivalent fractions using visual models, multiplication, or division. Have your guided notes ready, and let's tune up our fraction knowledge. All right, this bottle is 1/2 full, and the other says it's 5/10 full. Check out these other bottles. What fractions can be used to represent the amount of liquid in each of them? Pause the video here to record your thinking in your guided notes. We have 3/6, 4/8, and 2/4. The digits of the fractions look different, but each bottle is holding the same amount of liquid. All of these fractions represent the same part of a whole. They're equivalent fractions, or fractions with different numerators and denominators that represent the same value. Even though they're written differently, like how all these bottles have different labels, they're actually equal in value. 1/2, 3/6, 5/10, these equivalent fractions all describe the same value as 1/2. At first glance, each of these fractions looks different, but I wonder if any of them are equivalent. For each bottle, identify the fraction being shown and match it to another bottle that's showing the same amount. Pause the video here to record your thinking in your guided notes. We have 1/3, 6/8, 3/9, and 3/4. Which bottles are filled with the same amount of liquid? When we compare, 1/3 and 3/9 are different fractions, but they represent the same value. They're equivalent fractions. And 6/8 and 3/4 are also equivalent fractions. We could tell these fractions are equivalent based on these visual models, but how else can we know if fractions are equivalent? All right, let's take a closer look at this bottle labeled 1/2. We can think of it as one big part out of two equal parts. But what if, instead of two parts, our whole was broken into 4 equal parts? How many fourths will fill up the same amount as 1/2? One of the 4 parts wouldn't be enough, but 2 of the 4 parts represents the same amount as 1/2. That's why 1/2 is equivalent to 2/4. We know visual models can be helpful for finding equivalent fractions, but check out the digits of these fractions. Do you notice any relationship between the digits in 1/2 and 2/4 that could also explain why they represent the same amount? 1 times 2 is 2, and 2 times 2 is 4. So both the numerator and denominator are being multiplied by 2 to get the equivalent fraction, 2/4. We also know that 5/10 is equivalent to 1/2. What relationship between the numerators and denominators can you observe with 1/2 and 5/10? Pause here to record your thinking. This time, both the numerator and denominator are being multiplied by 5. It doesn't matter if it's 2, 5, 6, or any other number. As long as we multiply the numerator and denominator by the same amount, the value of the fraction stays the same, and we can find an equivalent fraction. Try finding a fraction that's equivalent to 2/3. This jug of coolant holds 6/12 of a liter, and this one holds 6/9 of a liter. We can use multiplication to decide which of these is the equivalent fraction. When we multiply the numerator of 2/3 by 3, 2 times 3 equals 6, so both numerators of these fractions work, but we still need to look at the denominators. Remember, we need to multiply the numerator and denominator by the same amount to find an equivalent fraction. 3 times 3 is 9, not 12. So 6/9 is equivalent to 2/3. We know multiplication can help us find equivalent fractions, but can you think of another operation we could use to find them? These bottles of brake fluid have 12/18 of a quart and 4/6 of a quart left in them. We could use a visual model to figure out if they're the same amount, but we can also use the relationship between the numerators and denominators. What do you notice about 12 and 4? And 18 and 6? How could we figure out if these fractions are equivalent? Pause here to record your thoughts. You might have noticed that 4 times 3 is 12, and 6 times 3 is 18. But is there a different operation we could have used? You got it! Since multiplication and division are inverse operations, we can use division. 12 divided by 3 equals 4, and 18 divided by 3 equals 6. Since we've divided the numerator and denominator by the same amount, we know 12/18 and 4/6 are equivalent fractions. Let's find out if there are other equivalent fractions to 12/18 using division. Besides 3, what else can both 12 and 18 be divided by? They're both divisible by 6. Pause here to record the equivalent fraction that can be created by dividing both the numerator and denominator of 12/18 by 6. "12 divided by 6 is 2, and 18 divided by 6 is 8. So an equivalent fraction to 12/18 would be 2/8. Whoops, you're right, Mia. The model of 2/8 doesn't match up with 12/18. I better check my math. 12 divided by 6 is 2, but 18 divided by 6 is 3, not 8. 12/18 is equivalent to 2/3. Good catch, Mia. So, what have we learned today, besides the fact that there are many ways to show the same value? Well, now you know that equivalent fractions represent the same value using different digits. You also know visual models, multiplication, or division can be used to identify and create equivalent fractions. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with equivalent fractions. And remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time.